All right, thanks, Steve. Is my screen visible to you?
It is to me, yes.
All righty. Yeah, so we are number 27 in the webinar series. Again, we like to do a mix of topics. There's a lot of announcements that come up. In between those announcements, we like to fit in some best practice webinars. Those are usually quite popular, and so today will be one of those. And like Steve, one of my favorite tools is also the Query Builder because I'm not so good at writing SQL. This is going to be one of those webinars where there are some demos, but they're not super impressive. They're more sort of use cases, and then we'll really get into the how-to part. This is more of a how-to kind of webinar, so there will be a bit of slides after the demos. But in the spirit of the tech webinar series, we always demo before we give you guys slides, so it gives you a chance to watch something before you fall asleep. So we'll go through a couple use cases here. In the demo, I'll take you into the code of each one. But just overall, the reason I picked this topic is that I find that two things. One is that people seem reticent to use the Query Builder. I think there's a combination of the intimidation factor. Maybe they didn't really know quite what it was for. But it's a lot easier than you think, and it's way easier than doing raw SQL. So we're going to break it down. And the other thing I see is that people have some challenges using it as well. I think it has to do with maybe the syntax. There's the call chaining, the Fluent API can trip some people up as well. So we'll take a look at that to make sure we resolve any of those questions. But let's dive right into demonstration here. So the first example that I want to go through is just really a custom value list. In this case, let's just say we want to have a list of addresses from a table. In this case, it's just example data customers, and we want to format them or do something to them. I'm doing something simple here, which is just to concatenate those addresses, the different fields of the address, city, and country, and put them together in a list here so that I can choose, say, a shipping address or something from a list. Pretty straightforward use case. A lot of times this gets hooked up to a global method value list. It doesn't have to be. You can also programmatically add those items to the list. That's not so important, but let's jump into the Query Builder side of things. So we have here, this is actually the wrong one here. Demo 4, I think. Load value list. All right. So the first thing we always do is we create the query object. And we're going to go through the different parts of the query when we wrap up in the overview, but for the value list, we're really concerned with the result portion of the query. And as you know, a value list always has display values, and optionally you can have real values if you're storing a primary key but showing a display field. So in this case, our display value is really that concatenation of address, city, and country. Now, in this example, one of the things that I wanted to show is that when you are working with the result part of the query, you can add columns, but you can also add other things like functions, aggregates, even subqueries or literal values. So this is one case where instead of adding just a column, we're actually adding the results of a function. And you can see that we call the concat function, which is available on any QB column. So again, we put this in the result portion of the query and we add, and then you can see you get code complete for really any of the functions that you might want to call on a column. And we chose concat, but you could pick something which is absolute value of math or something like that. So this is a real common use case that we have to create a custom value list. When you're making a value list, you might also want to do a sort so that they show up in a particular order, not the order of primary key or something. So we use the sort part of the query. And again, we just add conditions to the sort part. And really what you're adding to a sort will be pretty simple. It'll be one of these Query Builder columns, and you'll just add the ascending or descending switch to it. So at the end of any QB column, you can do ascending or descending, and that will indicate which order that you want to do the sorting on. It does matter what order you add to the sort. This will sort first by address, then city, then country if the addresses happen to be the same. It's worth pointing out too that you could do you can't just sort on columns. You could also sort on related columns through joins, and we'll get into joins in a little bit. The way that I'm loading the data is by calling get data set by query. Get data set by query takes the query object plus an optional limit, so you can limit the results. In this case, I put -1 to indicate that it will be unlimited. I want to get all results in the query. So you want to be careful with that if you have a really large result. In this case, I'm just calling set value list items with the data set directly on the element. I could also do application.set value list items, which will sort of do it globally anywhere that that's being used. I could also put this in a method which is hooked up to a global method driven value list so that it's called sort of automatically anytime the value list needs to be refreshed. So that's one of the most common places where you'll find this kind of query. Okay, so that's example one. The things I want you to remember is that you can put functions in the result and how to add things to the sort.
Sean, something worth noting is on the line where you have print SQL, I find it very helpful. You can use the database manager call get SQL to actually put that in an application output and check your actual SQL before you in the console. There's also get SQL parameters, which will send your parameters as an array also to the console. And I find that very helpful when I'm building the query. If I need to use like Microsoft SQL Studio Manager or something to check my query or to fine tune it, it's really nice to be able to see that as an actual query string.
Yeah, thanks for pointing that out. I was planning to mention that. I use it all the time in debugger too. When I'm just looking at stuff, I print out what the query is of a query object or a found set query. In this case, the reason I was storing that to a form variable that I could put right on the form here. So every one of these examples, I'm printing to the screen what the underlying SQL is, and I think it's a nice reminder of the SQL that I didn't have to write when I see that, because it gets pretty long pretty quickly. This is just a simple example.
And one thing also to note is that the Query Builder takes care of protecting the parameters that you're sending. You see the question marks; those are the placeholders for the actual parameters. So you don't have to worry about in the old days when you were writing your own SQL and then you wanted to pass parameters as an array, you would have to remember, well, did I put all these parameters in the correct order? And now the SQL Builder takes care, or the Query Builder takes care of that.
Yeah, that's right. Another example here, this one gets a little bit more complex. I'm going to do this is for sort of searching and loading records. I spoiled the surprise because I already had some stuff up here. But in this case, let's say I just want to do a text search and I want to be able to put in some words. And the reason I use this example is I want to get into nesting of logical conditions like ors and ands, because this is one of the places where I see the most difficulty with the Query Builder, and I want to try to simplify it for you. So in my use case here, I have a grid. It's just showing customers, and I want to be able to search those customers based on the name, the city, the region, the country. I also want to make sure that any of the words that I put in my search, all of the words have to match, but it can match any of the columns that you see there. So that's where all of the words have to match is the and the any of the columns have to match is the or. And we'll take a look at the result. But let's first put in a country like UK. We can see that there's various customers there. I'll put in London. Still, I've narrowed it down, but there's still some more customers, and I could put in something like North. And now I've narrowed it down to one customer. You can see that the SQL was changing down here as I was putting in my my additional criteria. and it's building that dynamically. So let's look at the that example. I think it's this one here. So again, this is a query based on the customers table. I'm only putting the primary key in the result, and that's because I'm going to load it right into the found set. We'll talk about that in a minute. The most important part of this query is the where clause. So really, when you get into building the where clause, it's quite common that you get into some logical conditions as well as some functions. So in this case, the reason it's dynamic is because I don't know how many words the user's going to type. And all of the words, like an internet search, all of the words should show up in the search results. It's not like it'll get, 3 out of 4 of them or something. So I'm iterating over the words, and I'm converting each word into sort of an uppercase. It's going to be used in a like function. So it's the uppercase version of the word, and it's surrounded by the wildcards to indicate contains. So we're going to match on that. So here's the part that I find trips people up, and that's that we're going to nest the ors and the ands. So really what we want here is we want to have a series of ors on the inside, and then those will be joined together with a series of ands. So any of these columns can match the word, but all of the words must match any of the columns. So we're going to have these 4 items in an or, and for every word we're going to separate it with an and. And if we flip back to the view here, it's kind of hard to read, but you can see that it's going with the 4 ors, and then we get the and in between another group of 4 ors, and then it's plugging in just those words in the arguments. And as Steve pointed out, it would get pretty cumbersome to build up a list of arguments and keep it all straight. And this really only took a couple minutes for me to write this query. So another thing that I see tripping people up is they think that if you do q.or.add, you're automatically modifying the original query in the where clause. This is the most common mistake I see, and this is the mistake that I made when I first saw Query Builder. It wasn't clear to me when I'm actually changing the query. And so what I would point out is that the only time the query is modified in this whole method, or at least the where clause, is here, when we add in the and condition. That's the only part, that q.where.add. Everything else is just generating these little conditions. So for example, when I call q.or, that returns a new or condition every time. It doesn't do anything to the query. It just gives me a little building block that I can stick stuff in and stash away and then put it back in later. So one of the ways I would say to simplify when you're working on the logical ands and ors and nesting is to, until you get the hang of it, skip the Fluent part. You can do, you can chain this all together in one call and do q.or.add, .add, .and.add, and on. What I would do is separate it out. You can see that every time I pass through, I generate a new or as a local variable inside that loop. So that helps to keep it straight, and then I can just add the stuff in there. And then at the end, I've also cached this as a local variable as its own and I'm adding to that every time and sticking it in the end. Again, we're printing out the SQL. This time I've included the SQL parameters. And finally, what I would point out is that in the prior example, we were loading records into a JS dataset, which is a very simple in-memory grid object. But in this case, we want to load it right into the found set, which is bound to the form that we're looking at. So all the data bound stuff on the form reflects the results of the query. So in this case, we call foundset.loadRecords, and we just pass in the query object. That's all that we need. Keep in mind, when you do that, the result of the query should just contain the primary key. If you add a bunch of stuff to the result, it's not going to work when you try to pass that in, because when a found set is loading, it just wants the primary key. You can play with the sort, though. If you apply a complicated sort and you want to include that in your found set loading, that will work. So I could have done that here. Okay, that's the second example. The third example deals less with the where clause and more with the select part, the result of the query. Let's say that we want to get into doing some aggregates. And this is really, I think, where the query builder comes into power, because if any of you have worked with Servoy for a long time and you remember find mode, I could have actually done this whole search in find mode. But when I want to get into using aggregates, then it's a bit more complicated. The way I would have done this, if I wasn't thinking about performance, is I would have made item count and order total as calculations. And loading those calculations in this grid would have produced a lot of queries, because these are bringing in related data and then summarizing it. So again, every line on this is just an order record, but it's going to give us the number of items in the order, and then it's summarizing the total of the order, which goes through every item and multiplies the quantity by the unit price. So you can see down here that we're calling sum, and then it's doing the quantity times the unit price. So let's take a look at how we do aggregates in the query builder. When the form loads, I call this load aggregates method. Again, I start with a query from the orders data source, and here we're only concerned primarily with the result portion of the query. So the first thing I do is I add the primary key. It's kind of convenient. You can just call add PK on the result. You don't need to know which column is the primary key or which columns, because it would support composite key. And then here we're going to deal with a couple of things. One, we're going to introduce using joins, and the second one is the actual aggregates. So in this case, if I want to show the company name, I'm gonna bring in related data. Also, if I want to aggregate the line items, the order details, I want to bring in related data. One of the nicest things about the query builder is that if you have relations established, then you will get code complete on all of your relations. So if I give myself q.joins, I get all of the relations that start from this data source. And if I go, say, to order details, I can again bring up my joins on the order details data source and say I could go over to products and over to suppliers. You get the point. So it's already using the conditions of those relations, so that the relation items, the two columns or the multiple columns and the operator will automatically be, and the join type will automatically be fed into that, building that join. So you don't have to build that join. You can build joins if you want. We'll talk about that in a minute. So after we add, or after we set up our joins, let's take a look at the aggregate itself. Basically, any column will have, and we'll look at code complete, will have the aggregates in them, and there's several. There's min, max, average, sum, and count. So any of these, you just have to go to the column and reference it. One thing that I think is really nice is that it's not just on the static columns that are in your database. You can also put aggregates on the results of a function. So we saw functions in the first example. We're bringing that back here, and we're calling on the related quantity, we're multiplying it by the unit price, and then we're summarizing the result of that. So we're calling an aggregate on a function to get the order total. The item count is a simple column aggregate. This is an aggregate on something which is calculated dynamically in the query. So one thing also that I want to point out is that if you're putting aggregates in your result, then anything which is not an aggregate has to be grouped, and that's just a SQL thing, because an aggregate it's an aggregate, so it needs to be summarized by something. So that's why we've put in here the customer and the order date, because an order can be to the same customer but on different dates. Finally, what I would point out in this example, different from the first and the second example, is that there's a third way that we can load the results of the query, and this is directly to an in-memory data source. I don't want to get into too much details about in-memory data source because we just did a whole webinar on that a couple, I think 4 weeks ago. So you can go back and watch that webinar if you missed it, but this is sort of the query builder side of that. So at the end of this, I could just feed all of the results of this query into a data source. In this case, I've set up that data source in advance and it's bound to the form that we're looking at. But point out that you can also limit the results. So if you want to just truncate the results, you can do that. So again, this is a form which is bound to an in-memory data source which already has the schema defined for these 4 columns. And that's how we're able to get that. And this is way faster, way better performing than if we did calculations, and it gives us things like the ability to sort on the aggregates. So I can know right away that, you know, this order was the one that had the most items, or this order is the one that has, you know, the highest value. Okay, moving along, I have another aggregates example. Product aggregates. It's basically the same. It's this time we're looking at individual products and seeing the aggregates for them, so we can know, you know, which product by sorting had the total gross and sales, which one we sold the most units of, and also which one has been ordered the most recently. So this is basically the same as the one we just showed. If I look at the load aggregates method of this one, which is also called on load, it looks very familiar, so I'm not going to go over the different individual parts. The only thing that I would point out is that I added one more aggregate because we didn't have an example of min or max. I added one more aggregate here on the order date. And so you can see that I joined my way all the way over to the order from the product. So all the places where this product has appeared on an order, and then I get the order date, and then I get the max. So that now I can see the max, and when you talk about dates, is basically the most recent. So that's when I can find out when that product was most recently ordered. The last example I want to give is hopefully the most fun one. Because when we want to deal with aggregates, we might want to deal with visualizations. So I made a little sales analysis dashboard. And this is to just talk a bit about grouping. The other ones we did grouping because we have to, because it's in, you know, we use aggregates and we want to have the things we're aggregating by. Here we actually really want to visualize by the groups. And also I bring in the limit into play here because I want to limit it to the top 5. So we do top 5 units sold in categories in products, and the top 5 units sold by suppliers. So you can see that these match up. If I look at product aggregates and I look at total units sold, my #1 seller is chai with about 3,800 orders. And if I go to the sales, I should see the same. Yeah, chai is the biggest slice in the pie. So let's take a look under the hood here. You can see down here, this is actually 3 different queries to support the 3 different charts. So in this case, I start with the query based on the order details. And what I do is I set out the aggregate right away, because I'm going to reuse it. So that's one thing I want to show you, is that if you get into something where it's a bit more programmatic, a bit more coding, you can always store. You don't have to add things into the query right away. You could always just create it and then hang on to it. In this case, I'm going to reuse that aggregate 3 times in 3 different versions of this query. So I just go ahead and I summarize the quantity. That gives me the total units, and then I can reuse that aggregate in whatever context I want. The same goes with the sort. Because we want to do the top 5, I want to sort by the aggregate descending. So that's another thing you can sort by. We showed already sorting by a function. Now we can sort by an aggregate. So here we're gonna start the first by the product. Again, I'm going to set out the related column through that join sort of in advance because I'm going to reuse it in several places. I'm going to add to the result, so we're just going to add the product and then the aggregate, and then I'm going to add the product to the group by. And then I just run it and I feed that data set into my chart. I don't want to get into the details of how to render the chart, but I'm just passing in the data set and it renders it pretty easily. Then what I do is I reuse the query. I just make a reference to my supplier related column, and I call clear on the result, and then I just add supplier and the aggregate back in. So I'm reusing that aggregate here. It's just in a different context because I've cleared the group and I add this supplier to the group. So now I'm just summarizing by supplier. So the same aggregate 3 different ways. And again, I just print out the SQL and add it to a different chart. And I do the same thing down here with the category. I create the category relation, and then I add it to the result and I add it to the group by, clearing both of those first. So I'm reusing parts of the query here just to make things a bit easier programming wise. So I just wanted to show you this example, number one, to focus a bit more on grouping as opposed to the aggregate itself, and also to show how you can reuse parts of the query. You don't have to just do it all in one big chain call where you're adding everything into the query. Finally, I would just point out that every time I load the data set in each one of these, I'm passing in a limit. We're doing top 5 in those charts, so I'm just saying what the limit is, top 5. I could change that easily and even make it dynamic and something the user could choose. So that's a good one to end on, because we see people spend a lot of time building screens like this, and I built this morning before the webinar, just about an hour ago. So it's a way to make this a lot simpler. We're running a bit out of time. I do have a lot of slides for review, not a lot, but more than usual, because usually we focus on the demo. But I just want to recap what we saw, because there's a lot of information. And we'll leave time for some questions. So again, why you would use the Query Builder API. You should not be writing handwritten SQL. It's error prone. It's not very productive unless you're a SQL guru. So for me, it's incredibly productive because I stink at writing SQL. But a couple other things. One is that the Query Builder generates cross-database compatible SQL. So we're not doing stuff that will work on SQL Server but not on MySQL or something like that. The other thing is that it's strongly typed. So you saw that I get code complete on all the stuff from my data model. That's hugely productive. You also get programmatic manipulation, so I can sort of store stuff and come back and later reuse it, and so you saw examples of that. That's hard to do if you're just like parsing strings. And another thing that we didn't really point out, but I just sort of take for granted, is that it handles data types. Like I could pass a date into the where clause. I don't have to like format a date string and say where order date is greater than, and then put in a formatted date string and hope that I didn't mess it up, which I would. I can just pass in a JavaScript date and let the Query Builder engine just handle it for me. So the same goes for strings and numbers. It's quite nice. There's several key parts of the query, and I think once you learn these, it gets less intimidating. So there's the result, and remember that you can put lots of different things in the result. You can put in columns, of course, but also aggregates, the results of functions. We didn't do a subquery example. I thought long and hard about a good example, but I didn't come up with one that I really liked. But I do have a slide about that. You can also plug in literal values. So if you just want to do select, 100 or select 1 plus 2, you could put that stuff in. Sometimes that's needed, and that's quite easy to do. There's the join part, the group by part, the where, the sort. We didn't talk about the having, but the having part of the query is needed if you want to use aggregates in a where clause. So adding columns, we saw, is pretty easy. You just add it. You can reference the column if your query object is strongly typed. You can also alias it, which is sometimes needed because you might do 2 different versions of that column in different places for different reasons. It's also easy to add the primary key without knowing what it's called. I said you could add literal values. This is what it looks like. You just call the add value function of the result. You can also alias that, of course, too. adding functions is one of the primary reasons people choose to use the query builder. So we saw the concatenation example. You can get a bit more fancy. You can mix and match functions. I could have done coalesce, which will do sort of a default value if I get a null. So if any one of those fields were null, I could have just done a blank space. You can add aggregates to the result as well. So we saw how to do that. Again, you can always alias stuff when you're adding it to the result. And we also saw an example where we did an aggregate of a function. So you can string this stuff together and call it one thing in the result. Just one thing to note, when you are doing aggregates, you always got to put the non-aggregate stuff in a group by. Otherwise, it will give you an error. We didn't do an example of subqueries, especially in the result. That's pretty uncommon, but you can add the results of a subquery to the result. When you do that, it just has to have only one resulting field in the subquery. Building conditions in the where clause is pretty straightforward, except for when you get into the nested conditions. But it's pretty much you do the where and then you do .add, and then conditions are really you can think of them as functions of the column itself. So company name .equals, product name .upper, phone .not, and then whatever condition comes after that. There are top level conditions as well, so you can do q dot top level functions. Q dot functions dot, and then you'll get a list of functions where it's not coming off of a primary column. So this is the format I usually use when I'm working with Query Builder. The API is Fluent, and by that I mean is that usually the methods of objects will just return the object again itself or the object that it created. So you can chain together. This is how I would have written the nested ors and ands that we saw before, where I would do where.add and then or.add and then back to the and.add. That can get really confusing, so my advice is that you format it with indentations, and that will keep the levels of the query, how deep you are in the different conditions, very clear to someone reading the code. But keep in mind, you don't have to use the Fluent style. So when I'm working with customers, a lot of times I get an email or a phone call that I've been spending 2 hours on my query. I don't know why it's not working, and it's really just a matter of the way the where clause is put together. So if you don't want to use the Fluent style, you don't have to. Just store things in variables, and just remember that the only way to modify the query, at least the where clause, is by calling q.where.add. So q.or.add doesn't do anything. It just generates a new condition, which then you can put in inside another condition or add it directly to the where clause. You can do subqueries in the where clause. I didn't have an example, but this is a real honorable mention because this is also pretty hard to do if you have to handwrite SQL. So in this slide here, we're looking at a second query, which will return us a list of customer IDs, and then I use that in the where clause of the first query, the outer query. So I say where a customer ID is in, and then the subquery. If you're using the in operator, you can also just pass in an array, and that's another place where it's really nice that you just have an array of JavaScript stuff, and the Query Builder, formats it for you. If you're new to Query Builder, just remember you can use your relations. If you find yourself building your joins yourself, you might be working too hard. It may be even appropriate to create a relation just to use in Query Builder. It's not a bad thing to have a sort of statically defined object rather than dynamically making one. And so you can reference these just on the joins of the query itself or any of the other QB joins, so you can chain them together. If you really need to build them, I didn't show an example of this, but you can just do query.joins.add, and then you have to specify the data source, the relation type, and you can give it the alias. And then you add the conditions. So you do the join.on, and then you add the join on conditions, and those will just be those conditions, of equals or greater than or something. By the way, when if you're ever working with part of the Query Builder API where it's dynamic like this, like we don't know, I should say the IDE doesn't know by reading your code that it's going to be based on order details, you can just give it a type tag and then you'll get code complete. So the next time you go to use that join object, you'll get all the columns and all the related joins that you get in code complete. So make sure you take advantage of the JS docs. Sorting is really easy. You just do sort.add. Remember that it matters what order you add them in. And you can use related stuff as much as you want. So that's quite easy to do. Just keep in mind performance. Sorting is one of the things that can kill the performance of a query. So if you sort on something which is an index and you have a huge table, you know what'll happen. Not that often we see this, but it really has its use case. If you want to do something where you want an aggregate in the where clause, that's not legal in SQL. You have to use the having clause. So if you've created an aggregate and you want to use it in a condition, that condition can't go in the where clause. It has to go in the having clause. It works just like the where clause. You just do q.having.add and then your condition. In this case, I want to find the total units sold between 1 and 2,000. We saw 3 different ways that queries were loaded. The simplest one is just to load it into a data set. That just gives you that kind of in-memory grid. You can always limit those by passing in a limit. You can also just give a query directly to a found set and it'll change its query and load those records in the found set. Doing limit in that case doesn't really do anything because a found set already limits it to sort of its internal page size. Keep in mind that when you do load a found set based on a query, the result portion of the query should only contain the primary key. It doesn't make sense to have other stuff in the result because the found set doesn't care about that other stuff. It just wants the primary key. Finally, and probably most powerfully, you can create an in-memory table based on the result of a query. And we saw that in the aggregate examples I showed you. We were just pumping the results of that right into an in-memory table, which was already bound to design time stuff on a form. So that can get you a lot of productivity. That concludes this. I know I went over, but it's a pretty big topic. I've been meaning to get this out to you guys for a while, so I'm happy I had a chance to do so. I saw some questions coming in throughout the talk. Steve, can we have a look?
We've got one question, how to make data source flexible, i.e. having a variable for example data in data sources.db and then the DB server. I think what he's asking is, can you pass the names of either the server or the data source as a variable to the create select call?
Right. Yeah, so you can do that. It's not in the create select because that's already using this statically typed data source of whatever table it is. If you go to the database manager API, you can do database manager dot I think it's create select. I'm not sure. And then you can pass in the data source name as an argument. So if you don't know it at design time, but you're going to know it at runtime, then that's the way you do it. In fact, that's the way you used to have to do it before we added the data sources part to the solution model and giving us the statically typed query builder stuff. We used to have to guess everything. So it's quite nice, but if you can't do that, I think it's database manager create select. When you do that, if you do know it at design time, but for some reason you haven't done the data sources approach, remember to use the JS doc to give a strong typing to your query builder objects.
The other question is it possible to get the SQL with the parameters already substituted? I think is in an output, like the get SQL command.
Yeah, I mean, you can write a small routine. No, there's not a call that supports that, but basically you iterate over the arguments, and then you can just first you call get SQL parameters, you iterate over them, and you just call string.replace, because that'll string.replace just replaces the first occurrence. So as opposed to utils.stringReplace, which replaces all occurrences. So if you do the JavaScript built-in string.replace, so like the get SQL and then .replace, and then you just keep doing it until you've looped over all the arguments. You could write a little routine and then use that anywhere you want.
That was it for questions. I just wanted to make one comment about making your own joins without a relationship, or even with a relationship. The thing that tripped me up for a long time was the type of join. If you're using it through a relationship, is going to be determined by the setting that you use for that relationship. And the default, I think, is generally left outer join. And so just be aware that when you're using a relationship to make a join, unless you've made a change to the default for that relationship, it's going to be a left outer join instead of an inner join, which is commonly what I expect it to be. I think you can. I'm not sure. I guess could you change it? Like, could you make a variable using joins dot the name of the relation and then change the? I don't know if you can change it after.
If you use one of the built-in ones that comes with code complete, I think those are immutable.
Right.
But if you, although no, maybe not. Maybe they just generate and return one, which is mutable. I never tried that. The alternative is if you do query.joins.add, you can give it a string as the relation name.
Okay.
And then it will, and then you can do stuff to it. So you should be able to do like set the join type. It's just join type equals, and then there's a constant you pass in.
And
in that one slide that we went through.
The constants for join types are under JS relation or relations in the solution model.